We are going to be writing quite a few kind of definitions, but the most important thing is we are going to be sketching some graphs today. So when you see a graph like this one, do your best to sketch it as best as you can in your notebook. You don't have to make it perfect, but the most important thing is that you get the nice shape of it, so this U shape of it, and that when we're going to be labeling it, you make sure that you label all the different parts. All right, so again, sketch it as best as you can. Doesn't have to be perfect, but as long as you label everything, I'm happy. Can I get a volunteer to read what is a quadratic function?
Are we writing this down?
Yes, ma'am. But who can start us off by reading? Actually, and let me actually change that up. You're going to write down two parts to this, the parts that I'm highlighting. So the first sentence and the last sentence. And who's going to read? Otherwise, I'm going to be calling on someone.
All
right, go ahead.
A function that can be represented in the form of f of x equals ax squared plus bx plus c is called a quadratic function.
Good.
The terms a, b, and c are constants where a does not equal 0. The greatest exponent of the variable x is 2. The most basic quadratic function is f of x equals x squared, which is the parent quadratic function.
Awesome, thank you. Okay, so like I said, start writing this down. I'll give you guys about a minute. You only have to write the green highlighted words and the orange highlighted words. You don't have to write the stuff in between. Okay. So when you're done writing the definitions, basically everything that you see underneath, I want you to copy it exactly like you see it. So we're going to copy the equation, and that's our parent function. You're going to copy down the table, which we're going to fill it in ourselves. And then to the right of all of that, you're going to copy down and sketch out that graph. Now, like I said, it does not have to be perfect, but try your best to sketch it nice and neatly. And when we label things, that's the most important part. So I'll give you guys another minute to copy down those things. All right, couple more seconds. I'm not going anywhere, so if you're still copying, that's fine, but now we gotta multitask a little bit. What we're gonna do now is we're just gonna fill in the table. And when we fill in the table, what's gonna happen is we're just gonna plug each of those numbers into our function. So I have a lot of x values, and I'm just gonna use those as my input values, plug them into the equation, and see what I get on the other side. So starting with the easy, I always like to start with the easiest one. Which of those input values would be the easiest one
Will be the easiest one.
to plug in? Yeah.
-1.
-1 sounds easy?
To plug in, may you repeat, like break it down a bit?
Yes. So I have my function equation, f of x equals x squared. I'm going to be plugging things into it out of this table. Just like we always do. We plug those in, see what we get on the other side. So which of those numbers from the column would be the easiest to plug in?
Oh, 1.
1 is pretty easy, I agree. So I would either start with the 1 or start with the 0. Either one of those is going to be easy to do. But you said 1, so let's do 1. So I'm plugging in 1. And I'm squaring it. That's what my function is telling me to do. I'm doing 1 to the power of 2. What does that give me?
1.
Yeah, we got 1. So 1 comma 1. Now from there I can plug in 2. And again, I'm squaring it. So 2 squared, what do I get?
4.
4. Then I'm going to go ahead and plug in 0. What's 0 to the power of 2?
0.
0. Okay, so far, not too bad. Now let's keep going backwards. I'm going to plug in a -1, and let's see what happens. What would be -1 to the power of 2?
1/2.
Nope. Remember, when we put things to the power of 2, we're just multiplying it times itself. So -1 times -1. Good.
Oh, 1. I
Yeah.
thought the exponent was negative. I'm sorry.
Oh, I see. Nope, the exponent is 2. All the way down, notice that exponent doesn't change. It's a 2 every time. So that's different from exponential functions. In this case, it's always going to be a 2. So we're just squaring all of those inputs. And like Lauren said, -1 times -1 is 1. And now finally, I'm plugging in -2. And what's -2 squared?
+4.
+4. Okay, +4. So let's take a look at what happened. Looking at the table, what are some observations that you guys notice?
For both sides, they sort of stop at the same point. Well, not like intersecting, but on the same point, I think, like on different
Yeah,
sides.
yeah. So we notice some repetition, right? So I have a 4 over here and a 4 over there, where we also have a -1 comma 1 and 1 comma 1. So there's kind of repetition, right? Some of these values some of the x values go to the same y values. Now take a look at the graph. Looking at the graph, let's label each of those points. So here's -2 comma 4, and here is 2 comma 4. Here's -1 comma 1, and here's 1 comma 1. And then down in the center over here, I have 0 comma 0. So what's
Oh,
one way to describe what's happening on the graph?
the x is turn turned into a negative on the left side?
Yeah, that's a really good way to think about it. So kind of what you see on the right side, when you flip it around, you see the same thing on both sides. Notice that? It's kind of like the same, it's kind of like a mirror, kind of like the y-axis is a mirror, and whatever you see on the right side is repeated on the left side. Any other observations from what we see in front of us? Anyone else? How would you describe the shape of this graph?
A V.
A V? Any other letter you would use?
A U.
A U, yeah. So V is close to what it looks like, but we want to say U-shaped because the bottom of it, it's not really, you know how a V will come to a point, like it's very much like an angle. In this case, it's not really a point down at the bottom, it's curved, right? It curves a little bit. So a U shape is a good way to describe it. So we got U shape. And we've got some reflection. Remember I said it's like a mirror? So whatever we see on the left side happens to the right side as well. Yeah, Karina, the way you said it is really good. So a V would be a lot more precise. And it's not really a V shape, it's more of a U shape because it's a little more curved, it's a little less intense. Any final observations before we move on? All right, cool. Moving on. So I have the same exact graph. So I want you guys to actually copy it down again because we're going to label the heck out of it. So we're going to be writing down a lot of different things. So in fact, if you have notes written down, skip to like a new spot in your notebook where you have plenty of space because all of these key words on the left side, we're going to be writing the definition and we're going to be labeling it. So like I said, there's a lot of kind of definitions, a lot of labeling going on today because we're just kind of getting started and learning about these functions. So just take a moment. And when you write down these key words, leave a good amount of space underneath because like I said, we're going to write the definition. So so just leave, I know I didn't put a lot of space because I had to try to fit it on one page, but since you have plenty of space in your notebooks, leave space in between so that we can put the definition down. All right, I'm going to start labeling things out. If you're still copying it down, that's okay, keep going. But let's go ahead and start labeling. So first thing, the vertex. The vertex is, let me highlight it in pink. The vertex is the tip right here. In this case, it's at the bottom, so it's the tip. What I like to talk it like it's either the tippity top or the tippity bottom. In this case, it's the bottom. So right there is my vertex. And you can think of it as the point where the function turns. Okay, because you can think about it like the function goes down and then it goes up. It goes down, it hits the vertex, and then from there it goes up. So the vertex is the point where that function turns. And in this case, where is the vertex? Remember, this is the parent function. So on the parent function, where is the vertex? At what point?
Zero?
Yeah, 0, comma 0. It's at the origin. So the parent function always lives, you can think of it like that's where it lives. It lives at the origin. The vertex is on the origin. So that's my vertex. Then I've got my axis of symmetry. Axis of symmetry. I'm going to draw it first. So think of it. Remember how we mentioned that everything that's on the left side is reflected on the right side? It's kind of matches on both sides. So the axis of symmetry is the line that goes right down the middle. I'll draw it as a little bit darker. Axis of symmetry. So one more time. That's the vertical line that passes through the vertex. The vertical line that passes through the vertex. And again, super important that you write down not just the definition, but also label it on the graph. Okay, next up we have maximum slash minimum. So every quadratic function is going to have either a maximum or a minimum, not both. And that just means you have to look at, does your graph have a tippity top vertex or does it have a tippity bottom vertex? And in our case, in the parent function, it has a tippity bottom. So you can think of it like that vertex is the lowest possible point that the graph is going to go to. It's not going to go anywhere lower than that. So in this case, we have a maximum. Or sorry, not a maximum. We have a minimum. I'm sorry. And when we talk about maximum versus minimum, we always talk about the y value. So the y value is 0. So this has a minimum at y equals 0. So the maximum slash minimum is the highest or lowest y value. Now I realized that I forgot to write where the axis of symmetry is located. So Really quick, going back to that, the axis of symmetry, in this case, we talk about the x value. So max and min, the maximum and the minimum, is talking about y value. The axis of symmetry is talking about the x value. And in this case, it's at x equals 0. Now I know this is probably feels like a lot of information, but we're going to do a few examples and we're just going to keep labeling it until we remember what all of these are. Next up, y-intercept. Oh, we know that. We've seen y-intercepts before. In this case, where is the y-intercept?
0.
At 0, yeah. So the vertex is carrying a lot of different hats. It wears a lot of hats in this case because the vertex is also the y-intercept and also it's the minimum. And then we'll talk about one more thing. So the y-intercept is where it touches the y-axis. Any questions so far? Cool, cool. So we've got vertex, we've got axis of symmetry, we've got the minimum, we have the y-intercept. What about the x-intercept? Where does it touch the x-axis?
At the vertex.
Also at the vertex. At the same spot at 0, 0. So the y-intercept is the same as the x-intercept. In this case. Now again, I'm going to show you a lot of different examples and they're not all going to look this way. But this is true for the parent function. Now I want everyone to catch up to this point because domain and range, I'm going to want to erase everything. So I'm going to give everyone about another minute to catch up to where we are so that I can erase after that.
Oh no, domain and range.
Domain and
I
range.
wasn't sure during that topic.
War flashbacks.
Yes.
All right, anybody still copying? Okay, going once, because I'm going to erase everything. Going once. Going twice. Okay. Okay, I'm just erasing because I want to be able to explain this as best as possible, because this is where a lot of people tend to get confused. So, domain and range. Who can remind me? Think back. Domain is what? In general. Good, Karina's got it. The input values. So all the inputs, and the input values also, another way to say that would be the x values. You got it. All the x values. So let's take a look at the x values. Now, I have arrows at the top. What do these arrows tell me about the function? What's happening here?
It is going to a infinite.
Yeah, It's going to infinity. It's never going to stop, right? So x values are all of the values of this graph going from left to right. Okay, because the x values are going in this direction from left to right. So let's think about this. This graph is going up, right? But is it going straight up or is it kind of going at an angle?
At an angle.
At an angle, a little bit, right? Slightly to the right and then slightly to the left. So as this graph goes up to the left, this is my right, but I think you're seeing it as your left. As it goes up to the left side, it's going up, but it's also going a little bit to the left at a time, right? And a little bit, and a little bit, and a little bit more, and a little bit more to the left, and a little bit more to the left. So as it goes in that direction, is it ever going to stop?
No.
No. So basically what's going to happen is it's going towards, what happens on the left side again?
It's going towards infinity.
And if I'm on the left side, I'm going towards
The left?
which infinity?
Which infinity? Oh, negative infinity.
Negative infinity. And if I'm going to the right, I'm going towards
Positive infinity.
positive infinity. So the domain is going from negative infinity all the way to positive infinity, and it's hitting everything in between. So what we say when I'm talking about the domain of this graph is going to be all real numbers. What that basically means is that it's going from negative infinity. Now remember, infinity just means like, think about the biggest number you know, and then keep going. Like it's never going to stop. It's never going to stop going to the left, and it's never going to stop going to the right. And because of that, since it's basically hitting every single number in between, we call that all real numbers. So the domain is all real numbers. Questions on domain? Okay. So kind of crazy. That's domain. Let's talk about range. So domain is all the x values, range is all the y values. Yeah. So now I'm not looking at the x-axis, I'm going to take a look at the y-axis. And let's think about it. My graph is pointing up, so if it's pointing up, where is it going towards? Infinity. On both sides. It's pointing up on both sides. So upwards, I'm going towards infinity. But when I look downwards, what happens?
Negative infinity?
Does it go that way?
No.
No. What happens? How far down does this graph go?
All the way to the origin?
All the way to the origin. Remember, this is the minimum y value. It doesn't go past that number. It goes to the origin and then back up. So it's never going to dip down below 0. So what that means is my range, what's the lowest amount?
0.
0. What's the highest amount?
4.
It stops at 4?
Infinite.
Infinity. So it goes from 0 to infinity. So this is the way that I write it, from 0 to infinity. Y is in between 0 and infinity. Or you can say 0 is less than y is less than infinity. And I can write that, let me just write that one more time a different way. So the range is from 0 to infinity. Because again, it doesn't go anywhere underneath the 0. So really it's just this. Questions on domain and questions on range, because I know that that's always the trickiest part. All right, take about 30 more seconds to write this down. And then we're just going to do 4 practice problems, and that'll be it for today. Oh, and by the way, I forgot to highlight this word before. I just noticed. Parabola, that's just the name of the shape. So remember how we said that it's a U shape? That's another word for it. So a parabola is a U-shaped graph. So go ahead and also write that one down. All right. All right. So let's do some examples. Now, you do not need to copy these into your notebook. I'm going to be cautious about what I say. Copying them down is going to be helpful, but if you feel like you don't have enough time, you don't need to do it right now, but you can always go back and watch the videos and then copy everything down. Because I'd rather make sure that everyone's paying attention and following me rather than worrying about getting everything down on their paper. So if you don't have time right now, that's okay, but we'll get to it eventually. Where is the vertex on this graph?
2.
And let's be more specific, a full coordinate point.
2 comma 0. No, 0 comma 0. I mean 0 comma 2.
0 comma 2. Good, the vertex is right here at 0 comma 2. All right, perfect. Somebody else, where is the axis of symmetry? Good, Juan is saying the y-axis, that's perfect. So it's right here, write down the y-axis. Okay, so that's my axis of symmetry. And remember, when I talk about the axis of symmetry, I'm going to label it using the x value that it passes through. So which x value is that y-axis passing through?
Which x value?
Mm-hmm. So
X
you're close, Juan, but which x? So if you think about the y-axis like it's just cutting the x-axis, where is it cutting it?
Oh, negative 0 comma 2. Well,
There, Juan's got it. 0 comma 0, right? That if you think about the x-axis and the y-axis is cutting it in half, where does the y-axis actually pass? It passes at 0. It passes it at 0 right here.
Oh, it's lopsided for me. I thought it was 0 comma. I mean,
right there.
like beside. I don't know how to explain.
Nope, the x-axis and the y-axis, they meet at 0. So that's where it's cutting the y-axis. So the axis of symmetry is at x equals 0. Maximum or minimum? What do I have in this case? Do I have a tippity top or a tippity bottom?
Tippity bottom.
Tippity bottom.
I mean tippity top. I'm sorry.
Tippity top. So I have a
Mix maximum.
Maximum. And the maximum is the y value. So what's the highest y value? The greatest y value?
The greatest y value, infinite.
How high up do I go on the y-axis? There's my answer. Y equals 2.
What?
The tippity top. It's a hill. Can you go higher than that hill?
Oh no, I'm sorry.
No, you cannot. It's okay. We're getting used to it. Y equals 2. That's the highest number that you can possibly reach. After that, you go straight down. Where is the y-intercept?
Where's the y-intercept?
Mm-hmm.
On 0. No.
At
No,
x equals 2?
x equals 0.
That's my y-axis, y-intercept?
Where x equals 0.
Where x equals 0. So try again. Where is the y-intercept? Don't overthink it. Where is it crossing the y-axis?
On 2.
On 2. So it's not x equals 2. There you go. It's at y equals 2. 0, comma 2. Now, the parent function, if you remember, if I go back, the parent function had the same x-intercept and y-intercept. They were both at 0, comma 0. But here, take a look. Where can I find the x-intercepts? There's more than one.
Oh, negative 2 comma 0 and 2 comma 0.
Good. Negative 2 comma 0 and 2 comma 0. There's 2 of them. So the x-intercepts are 2 comma 0 and negative 2 comma 0. Questions so far? We've almost got everything. Questions, questions, questions?
No.
Okay. So now domain and range. Kind of running out of room, but I'll do it down at the bottom. I'll do domain in red. Okay. Oops. The domain of this graph. So think about it. The graph is going down, but while it goes down, is it going straight down or is it at an angle?
At an angle.
At an angle. So while it goes down, it's also going towards the left. And while it goes down, it's also going towards the right. So the domain goes from negative infinity all the way to positive infinity. And what do we call it when it's hitting every single number? We just wrote it down.
All real numbers.
All real numbers. Then the range is the y values. So think about it now. How high up does the graph go? How high up? Okay, David, I just need to finish this one problem. How high up does my graph go?
It doesn't go up.
It sure does. It's a hill. How high up does it go?
Oh, 0 comma 2.
To the 2. How far down does it go?
How far down does it go? Infinite.
Which infinity?
Negative infinity.
Negative infinity. So from negative infinity to 2. Why? The range is every number from negative infinity up till 2. So we covered a lot today, a lot of new information. We're going to continue with all the new information tomorrow. and then keep going from there. So like I always say, when we're starting a brand new topic, the most important thing is to make sure you have the basics. And once you've got the basics, it's going to be a lot easier to learn everything else. So if you feel like today's work was a little bit challenging, I highly encourage you to go back and watch the video. Karina, yes, I'm going to upload a Khan Academy, but you don't have to do it. It's not due till Friday, and it'll be easier to do it after tomorrow's class. So don't stress about it yet. I will put it up, and you can try it. But if you don't feel like you understand it, then don't do it until tomorrow. All right? Any other questions? All right, so go ahead and have a great day, everybody. I will see you all tomorrow.
See you tomorrow, Ms. Lopez. Have a nice day.
Have a nice day. Bye.
Bye.